this one over here. Okay, and go to that. Okay, so we're looking at example 9. Again, when we're doing U substitution, we're always looking for that inside function and the outside function. It's a little bit tougher to see on this one. Okay, so I am going to start by rewriting that. All right. I'm going to rewrite the sine to the sine fourth power as sine of x to the fourth power cosine x dx. All right, so now what is the inside function? Sine x. So u is going to be sine x. So anybody, if you need your colored pencils, I can get them out. Okay, I just didn't put them on tables. Sorry, I forgot. But if you need them, I can grab them. All right, what is du then? Cosine x. Okay, so we got to be really careful now, right? Because you had them all down for derivatives. We've got to go back and refresh now that we've got our integrations. You got to decide which one's negative and which one's not. Okay, so derivative of sine is positive. Integral of sine is negative. Okay, so I'm going to and I noticed that, let's see, I've got cosine and dx, so I'm ready to substitute in. Okay, this one was kind of almost nice. All right, so we've got parentheses to the fourth. The u is going in for sine. And then for the cosine x dx, oh, I lost my dx there, didn't I? I'm putting in du. All right, take a minute and finish the integration. You can do it. Finish it off. We agreeing with where I'm going here? So u to the fifth over 5 plus c, and then sine of x to the fifth over 5 plus c. You could also rewrite it as 1/5 sine to the fifth x plus c. That's acceptable as well. And remember, if it was multiple choice, you'd need to understand both. Okay. Okay, let's keep going. Oh, too fast.
The cosine x, did you just get rid of that?
The cosine x, remember, is part of the derivative piece. Were you here for U sub? You've been here this week? Okay, so when we are doing U substitution, in order to substitute in, the rule is our derivative has to be part of it. So the derivative of whatever our u is has to be part of it. So when we substitute in for that piece, it becomes du. It gets replaced with du.
Why isn't there like du in the end part?
Because when we integrate, the integration takes away the du or the dx. Okay, does that make sense? Sort of. Okay. All right, let's take a look at example 10. All right, what is my inside function? Good, so u equals 1 plus x squared. All right, so du equals 2x dx. Okay, so when I'm looking in my original function, I see 2x dx. All right, so I'm ready to substitute in. I'm going to have square root of what's going in for the 1 plus x squared. U, good. And then for the substitution in, I have to have 2x dx, and I have both of those things. I get to substitute in du for that part. remember the du or the dx or the dt, whatever it is, that's the representation of the width of the rectangle. Because remember, what we're really doing is we're taking all those little rectangles we did in Riemann sums, and integration is the way to add up an infinite number of those, okay, to make our estimate the best of our integration, okay? So when we integrate, that's like taking the area of it, so that's why it goes away, okay? All right, so we're going to go ahead and do u to the what power? 1/2. Notice I haven't done the calculus yet, right? I've not done the calculus yet. I've only done algebra. All right, so now we're going to do the integration. We're going to add our fancy one, so 2/2. So u to the 3/2 divided by 3/2 or multiplied by what? 2/3, and then plus what at the end because it's indefinite? C. Good. All right, we need to substitute in. So we put our u back in. So I'm putting back in the 1 plus x squared. Once it's in a fractional exponent like that, you would not see them go back to a radical. Okay, they'll leave it in the fractional exponent. The only exception is if it's like a 1/2 power, that might go back to a radical. But anything bigger than 1/2, they'll leave it like that. Okay. Let's take a look at the left-hand column, okay? Because we're going to switch gears just a little bit. We've been doing ones without fractions, right? So all of a sudden, example 11 has a fraction. So let's review a little bit. We had something last week that we talked about. 1/u or 1/x. What was that integration? Do we remember? Yeah, natural log absolute value, technically of u plus c. A lot of times books will go through and say u is some inside function, and so it has it's the same thing as the integral of natural log of x. So. All right, for integrating fractions, so this is a handy tip. The u will never be on the top. So u will never be on the top unless it is natural log of x, and I'm not sure what's supposed to go in the back. So unless it's natural log of x, okay? If you see a natural log of x in the top, that's your u. Otherwise, your u is going to be in the denominator, okay? All right, so looking at example 11, my inside function should be my denominator. Okay, we'll see one with the natural log of x on the top in a few minutes, I'm sure. All right, so my u is going to be this. So u equals 2x plus 3. What does du equal then? 2 what? Dx. Good. Okay. I am going to do a little bit of rewriting so you can see that I actually do have 2 dx. Okay, so I'm going to rewrite the original really quick. So my 4 could be broken up into 2 times 2, couldn't it? So we got a little bit creative with that one. I still know 2x plus 3 is the u. I have 2 dx. So I can substitute in. I don't have to add in a 2 because we've already got it. All right. I'm going to choose to take this 2 when I'm doing my substitution step and move it in front of the integral symbol. Remember, that's one of our rules. All right. What am I putting in for the 2x plus 3? U. Good. And then for the 2x dx, I substitute in du. And typically, I will put it on the back part there, and I put a 1 in my numerator. Okay. Let's integrate it. So when I integrate 1/u, what do I get? Yep, natural log absolute value of u plus c. Good. So 2 natural log absolute value of 2x plus 3 plus c. Okay. Before I make it before we add trig to it, see if you can do 12. Okay? Remember, your u is going to be in your denominator. Look for your du in your numerator. See what you can do with it. wrote it wrong. I have a total typo in there, don't I? Shouldn't be a cubed in the bottom. What should it be? Squared. It's a squared. I'm sorry, I just caught that. So fix it. That was my fault. Give you a minute to fix it. Didn't mean it to be that hard yet. Okay. So my x squared minus 3 is the u. We got lucky and our entire du is there. Okay, so I'm just going to substitute in. So you've got the integral of, put your u in for x squared minus 3. Du goes in for 2x dx. All right, when you integrate 1 over u, what do we get? Good, plus c, right? And then natural log absolute value of x squared minus 3. At some point, you're probably going to get annoyed. We might not be there yet, but you're probably going to get annoyed by writing that step because all we do is then just substitute back in, right? I typically, at some point, you'll probably get to the point where we just write down this step after your u step because you know whatever is going to go inside there in that blank is going to be your u from before. Okay, so it's up to you where you take a leap. It's okay if you write the u in there. If you want to do the skip in the step, that's fine too. Okay. Don't want to skip too many steps, but that one is an allowable skip. All right, so let's follow the rules we just learned, okay? We said the only time we don't use the denominator as our u is if it's natural log, okay? So what are you going to use as the u this time? Just secant x. So u equals secant x. What's du equal to? Secant x, tangent x. Big hint. Look at what's there, right? So secant x tangent x dx is the du. All right, we're going to make it look a lot better. So I'm putting in u for secant x. And then for the secant x tangent x dx, I'm putting in 1 du. The 1 is just because we need something in the numerator. Okay, when you integrate 1 over u, what do you get? Good, plus c. And then again, we're going to substitute our u back in. So I'm substituting back in secant x. Okay. We'll do the next whole page is kind of some more, they're pretty basic ones. One of my favorite ones is on it though. And then after that we'll see if we can get into some inverse trig. Okay. All right. Ooh, too fast. So this one here, remember how we said we had the integral of tangent and you could memorize it? Same thing with the integral of, I think it was secant and cotangent and cosecant. We're actually going to prove it because it fits really well in with what we're doing right now with this type of integration. It isn't something you'd ever have to do again, but if you didn't remember integral of tangent and it came up somewhere, you could do it this way. Okay. All right, so we got to dig deep into our trig. Tangent is what divided by what? Good, sine over cosine. You see how I just created something with a denominator so it fits right in with what we've just been doing. Okay. All right, so our rules say the denominator has to be the u. So what are we going to use for u? Good. So u is cosine x. All right, so what is the derivative of cosine? I heard somebody say negative. Good job. It's negative sine x dx. Okay, I see sine x dx. What am I missing? The negative, which means to multiply by 1, I would have to multiply -1 times -1, right? That's what multiplying by 1 would look like with a negative. So I'm going to put a negative in front here and a negative in front there. If you want to write a 1 in front, that's fine. You don't have to. It's technically like multiplying by -1 over 1 over -1. It's the same thing. Okay? Just have to make sure you're multiplying by 1. All right. Let's set up the integral. So negative, I'm putting the u in for cosine. And then the du goes in for the negative sine x dx. Okay, this negative is going to hang out in front. When I integrate 1 over u, what do we get? Natural log absolute value of u plus. If you don't know that one after doing it like 4 times now, right? You need to make sure you got it. Okay, it's going to come up a lot. It's one of their favorites. They like natural log. Okay, negative natural log absolute value. I'm going to go ahead and plug in the u, which was cosine of x. Which if we went back a couple pages in your notes, that's what we wrote down. So integral tangent is negative natural log of cosine of x plus c. All right. Example 15 is like one of my favorite problems. I pretty much guarantee you're going to see something like that on a quiz. So you might want to, star, bold. Mrs. Ballard said she loves this one, so we'll see it. Okay. All right, so the exception to the rule. The denominator is the u, except if there's a natural log. Okay. Do we have a natural log in it? Yeah. Okay, so I'm going to use u is going to be the natural log of x. What does that mean that du is equal to? 1 over x dx. Okay, I'm going to write that down, and then we're going to rewrite the integral a little bit so you can see it. Okay, so I'm going to take the 3 and I'm going to move it in front. And then I'm going to break this into the natural log of x, and then I'm going to break off the denominator and make it its own part, times 1 over x dx. Anytime you see that lone x in the denominator, it's 1 over x. Okay? So hopefully you're noticing that this came out really, really nice, right? So we've got the u, which is the natural log part, and then we've got the 1 over x dx is that part. So we're ready to substitute in. All right, so we've got the 3 hanging out in front. What am I putting in for natural log of x? What am I putting in for this? What am I substituting in for it? U, there we go. Okay. And then what are we substituting in for 1 over x dx? Du. All right. We're going to go ahead and integrate it. So we've got 3. We've got u to the what? Squared over 2 plus c. Good. All right, so 3 halves. I'm going to substitute my natural log back into it. There is one other way I can write that. We probably haven't seen this before because it just hasn't come up. You could also write it just like we do the sine or the cosine where you put that squared. It looks a little bit weird, but you can do it that way as well. You're probably more likely to see it the other way, but you should know both. All right. Out in the left-hand column. One of our favorites. When we integrate e to the x, what do we get? E to the x plus c. Super boring, right? So we almost always have a u substitution in there. Okay. All right. So in this first one, what is the u? For example 16. 7x. Perfect. So u equals 7x. All right. What does that mean that du is equal to? Good. So I need to add, I have the dx, right? I do not have the 7. I need to add in a 7 on the inside and a 1/7 on the outside. All right, so we've got 1/7 the integral. And then we have we're going to do e, right? The 7x becomes u. And then 7 dx is going to be replaced with du. Okay. So we have 1/7. When I integrate e to the u, what do you get? E to the u plus c. Good. So we get 1/7 e. My u was 7x plus c. All right. Let's take a look at 17. Okay. What do you think the u is on 17? Good. All right, everybody try 17 on your own. So we've all got the same u. See what you can do with 17. Give you a minute to do it. Okay. What'd you get for du? 2x. What happened there? Something went wrong. I have a typo again. Oh, that's too far. The other direction. Yeah, I totally reversed it, didn't I? The 2 I give you to do on your own, I totally reversed it. That should be 2. This should be 3. Okay, try it again. That should be 3. Okay, so see what you can do with that. It should be much better now. All right, let's see what we got. Okay, So your du should be 3x squared dx. Do we all agree with that? Okay, we have x squared and dx. What are we missing? 3. So I need to add a 3 on the inside. What goes on the outside? 1/3. Good. So we've got 1/3 the integral of, we know it's going to be e to the u. And then for the 3x squared dx, we're substituting in du. All right, when we integrate e to the u, what do we get? E to the u plus c. And then we're going to substitute in the u. So e to the x cubed plus c. Okay. We're going to do one more for sure here. Still got lots of time though. 16. Okay. One more before we have to learn a new formula. This one is going to be super weird. Okay. So it just is. Let me get back to it here. There's a little bit more to it than just. There's going to be all kinds of fun stuff we haven't done in a while. Okay. All right. So our rule is use the denominator, right, as the u. So I'm going to use my entire denominator as the u. U equals 5 minus e to the 2x. All right. I need to take the derivative of 5 minus e to the 2x. What do I run? What's the derivative of 5? Perfect. Okay, and I know that I've got to have the negative hanging out in front. What problem do I run into with the rest of it? What am I going to need? I need a chain rule. That's exciting. We're doing a chain rule now inside of a U substitution. I can't call it U, right? So I'm going to call it W equals 2x. So do my little chain rule side work here, okay? So that means that W prime equals what? 2. All right, and then we usually call something F, right? F equals the e to the negative e to the W. We already kind of wrote our negative down. So F prime equals, what's derivative of negative e to the W? And then you have to multiply that by the inside derivative, which was 2. All right, I'm going to write it down up here. I already wrote the negative. I'm going to put the 2 in front, e, and I'm going to substitute the W back in, which was a 2x. And then put a dx at the end. The good news is, does that look really familiar? Yeah, it was what was in the numerator. Yay, right? Okay, let's see if we can finish it off. So we've got u going in for the denominator, and then for the negative 2 e to the 2x dx, we're putting in du. Put a 1 in the numerator. All right. When we integrate 1 over u, what do we get? Good. Plus. Good. All right. Natural log absolute value of u. We're going to put in the 5 minus e to the 2x. Okay. Before we try to do arctangents, okay, we need a little bit of a brain break, all right, because we've done a lot, okay, and we're doing them quick, all right? There's just still so many of these different types. I want to make sure you see it. So everybody stand up. Okay, everybody standing up. Okay. All right. Okay. I'm going to bring this to... Where's it going? There. Oh, it's going weird. There it goes. You can sort of see. That's not the one I want to do because that one's too easy. I know, that one's too easy, isn't it? Okay. All right. Is that the one I wanted? I don't think it is. All right, that's the one I want. Okay, so talk about with your table really quick what you think that's a picture of. Okay, let's look at the next one. You ready? Okay. Now, what do you think it is? Talk about it with your group. All right. All right, we get sunglasses. All right, one more. Okay, stay standing. One more. Let's see what the next one is. I don't know what it's coming up because I can't see it anymore. All right. What do you think that is? Talk about it with your group. All right. There's the next one. Watch out, they spit, right? Have we not seen Aladdin? It could be the camel that lives over on the other end of town. All right, sit down. Okay. All right, let's talk some inverse trig. Sometimes you have to do that. You have to walk away, right? It's hard to have that discipline with math, especially when you want to get the homework done and you got it like in that one spot. When I'm talking about it with my daughter, I'm like, you need to get up and walk away for a little bit. I don't do this all. I don't go home and just grade and grade and grade and grade. I got to stop and move away from it for a while. Okay, so you got to take that break sometimes. All right, let me get back to, where's my, okay. We already wrote down the base steps to integration. We're not going to do this part. It was up at the beginning of the notes. So let's just look at, mine just totally blanked out, didn't it? That was nice of it to do. All right, so you get a little bit more of a break. We'll see if it'll actually reconnect. Or what was it? First period, it wouldn't reconnect. It's really driving me bananas. All right, it's verifying security. It says it's connecting. All right, there we go. So cross out the basics to integration. That one you can cross out. We already have that, or the steps. We've got that up at the top of the notes. Okay. These are the only two I'm going to test you on. These are typically the two that are on the AP test. All of them are technically fair game, but they very rarely come up. So we're going to focus on what we're going to get big money points on. Okay, that's where we're at this point of the year. The first one is arcsine. Remember that the A is representing a number, okay, and the U represents typically X. It's your variable. Okay, so when you're looking at it, it's 1 over the square root of a number minus an X. Lots of times it's a square number, but not always. Okay. All right, so this is, when you integrate that, you get arcsine of U over A plus C. Okay, again, in the second one, the A is the number, the U is the variable. This one is arctangent. What's goofy about arctangent is you have to remember you put 1 over A, arctangent, I don't want the parentheses, it's just too much, U over A plus C. That's a tangent, even though it doesn't look like it. And again, it is simply a formula you have to remember, okay? So once you understand that the format is there, you're going to use that formula, okay? And sometimes there's a U substitution built in. The first one is just going to be a straight arctangent, and then the second one we have a U sub built in there, okay? All right, we got them? Because I'm going to shrink it and go to the problem. So let's look at 19, okay? I am going to choose to rewrite 19 just a little bit. I'm going to take that 4 and move it outside. So you've got 4, the integral of 1 over, and I'm going to try to get it into that format, that squared format. Another name for 1 would be 1 squared, right? Minus x squared dx. All right, so what is the A part of that? The 1. What's the u part of it? The x, right? So I'm just going to simply substitute those in the place they go in the formula. I am recognizing that that's arc squared. I drop the 4 down, the coefficient, and I just write, sorry, I don't know what, did I say arc squared? That was really weird. Arc sine. Okay, arc sine of u, which is x, over a, which is 1, plus c. You could, of course, rewrite it without the 1 in the denominator. You don't have to. That is perfect. That's up to you. If it was multiple choice, I would not waste my time rewriting it again, right? You find the one that matches and you bubble the answer and you move on. We're going to have to practice bubbling our answers, aren't we? Because we haven't done that in years now. You don't think we need to practice bubbling our answers? Kind of like I made you practice drawing rectangles. 4th period laughed at me when I made them draw rectangles. All right, we good with 19? All right, let's look at 20. 20 is where we're going to get the U substitution come back in. Okay, so not only have we learned a new integral, we're now going to add U substitution to it. Okay, I am going to choose to rewrite it right away. Okay, because I definitely know it isn't falling into my arcs yet because I have that x in the numerator. Okay, so I need to hopefully be able to get rid of that, maybe using some U sub. What is another name for 9? 3 squared. Good. And another name for x to the 4th would be x squared squared, because I'm trying to start developing that format of the arcs. Okay. But I'm not quite there yet because of the x in the numerator. We are going to go ahead and use this as u. Okay. And I know there's 2 u's now running around, right? There's the U substitution u, and then the u that's in the formula for arc sine. Okay. So we're going to use the U substitution u. So u equals x squared. What does du equal? 2x dx. Perfect. Okay. We are going to integrate. Or sorry, we're going to use U substitution, not integrate yet. All right. I see my u is going to be this x squared, so I'm substituting that in. And then I am noticing, oh, what did I miss? What's missing for my du? The 2. So I need to add a 2 in here. What do I put on the outside? 1/2. So I got to add a 1/2 out there. All right. So I have the 2x dx. So I'm going to substitute in du for that part. Okay. The 1/2 is going to hang out. Is it arcsine or arctangent? Arcsine's got the square root in it, right? Arcsine square root. All right, so for arcsine, we just write arcsine. What's in the u spot right now? U is in the u spot, isn't it? So we're going to use u. Perfect. In fact, it might be better to write it in orange, right? Because I know I still got to sub into that. What's in the u spot? It's in u, right? I'm talking about the u spot from the arcsine. All right, what's in the a spot? 3 plus c. And then we still need to substitute our u back in, right? So 1/3 arcsine of u, which is the x squared, I'm going to use orange, over the 3 plus c. It should be 1/2 because I wrote it wrong. I had a righto. It's kind of like a typo, except I'm not typing. All right, we got it. Okay, let's see if we can see one that's not in arcsine. All right, looking at 21. Again, I'm going to try to, if I have a U substitution, great. It doesn't look like I have a variable in the numerator, so that's kind of good news. That means it's probably easier. It's probably just a straight arcsine, arctangent kind of thing. And again, the other clue would be if I tried to use the entire denominator as U, just watch, don't write it down. If I use the entire denominator as U, that would mean for my du, I would need to have a 2x. I do not have a 2x in the numerator, so I know I've got to try something else. Okay, so that's how you kind of eliminate it's not U substitution right now. Okay. All right, so I'm going to rewrite it a little bit. I'm going to move the 2. I'm going to use a different color. I'm going to move the 2 out front. Got 1 over, what's another name for 16? 4 squared. And then we've got x squared dx. All right, so what does it look like? Does it look like arcsine or arctangent? It looks like the same thing as our arctangent, right, that we wrote down over here. It looks like this pattern. So I'm going to use my arctangent formula, which says I got to do 1 over a. What's my a value? 4. So 1 over 4 arctangent of u over a. What's in the u spot? X over 4 plus c. Likely we would have the 2 go into the 4 and we would reduce that to 1/2 arctangent of x over 4 plus c. Keep in mind that they don't have to say arc, right? They could say tangent inverse or sine inverse. Depends on the author of the question. And they do use both interchangeably within the AP test. Okay? So you just have to know that they're both there. We will pull, when we start looking at AP tests, we'll look at the instructions, and I think it even says in the instructions that they're equivalent somewhere. Okay. All right. Let's see, we got 16. Let's see if we can get a couple more in. All right. Looking at 22. We just kind of exited this, hey, we've got this arc thing going on, and we've got U substitution going on. Kind of which one am I going to look at here? Because it kind of looks like it could be almost either one. I would start with U substitution, especially considering the fact that I'm noticing that I have an x to the 4th, and I know the derivative of x to the 4th is x cubed, right? So that U substitution might be the way to go. If it doesn't work, then I would go try my arcs, okay? All right, so let's use that denominator as U. So u equals 4 plus x to the 4th. What does that mean du equals? 4x cubed dx. All right. I have the x cubed dx. What's missing? 4. So 4 to the top, 1/4 to the outside. So we got lucky it was U sub. We don't have to mess with arcs. Okay. All right, so I have 1/4 the integral. What's going in for the 4 plus x to the 4th? U, good. And then for the 4x cubed dx, I am getting du. All right, when we integrate 1 over u, what do we get? Good. The natural log, the 1 over u, it comes up so much. You're going to see it on the AP test, okay? Multiple times. All right, I'm subbing in for my u. We've got 4 plus x to the 4th. Okay, so here is what we're going to do. I'm looking at what's left here. Use your calculator, find the definite. Those are not as... Okay, I'm going to stop there for today. I think we've had enough, okay? We're going to pick up from 23 tomorrow because all of a sudden, notice it changes to definite integrals tomorrow, okay? You now have enough to start the homework assignment. So work on the homework assignment. Make sure you've got this down and you can do U substitution. It's important. Okay. And then we'll pick up with definites tomorrow. Okay. I may have said, I don't know where I said we were ending today on the calendar, but that's where we're going to end right now.